polar coordinates. Now, this is a way of representing and graphing a point which is different from the way we have learned previously. Previously, we represented a point on a rectangular coordinate plane, also known as the Cartesian plane. Here, we will learn how to represent a point using what's called a polar coordinate plane. Now, in a polar coordinate plane, the point is represented using two coordinates as well. However, the first coordinate is represented by the letter r, which is also called the radius, and the second coordinate is theta, angle. Therefore, when representing a point in polar coordinates, the ordered pair looks like this. It's r comma theta. Therefore, to represent a point in a polar coordinate system, the coordinates will be within brackets r comma theta. So we will learn more about that, how to find r, how to find theta, and how to represent a point graphically. Here are the topics that will be covered in this lecture. We will first look at the polar coordinate system, understand how it is different from the rectangular system, and then we learn how to represent and plot points in the new system. We will learn how to find multiple sets of polar coordinates for a given point, and that is possible in this system. The same point can have multiple sets of polar coordinates. Next, we will learn how to convert a point from polar to rectangular coordinates and vice versa, which is converting a point from rectangular to polar coordinates. We will go on to equations next and learn how to convert an equation from the rectangular to the polar coordinates. And finally, it's vice versa, which is to convert an equation from polar to rectangular coordinates. We will now learn about the polar coordinate system, how it is designed, and how it is different from the rectangular coordinate plane. And then we'll also learn how to represent points on this new system and how to plot them. Now, in our rectangular coordinate system, we had the x-axis and the y-axis, and those axes intersected at a point known as the point of origin, and all other points were defined with respect to that point of origin. So if we have this blue point here, we would represent it using two coordinates, the x and the y coordinate. Each of these coordinates would be defined with respect to the point of origin, the point of intersection. In other words, x would be the horizontal displacement of the blue point from the point of origin, how far the point was along the x-axis, or how far it was displaced horizontally from the point of origin, and y represented how far this blue point would be displaced from the point of origin vertically, how far the point is relative to the point of origin along the x-axis or horizontally, and how far up or down it is relative to the point of origin along the y-axis, correct? So that is how we represented a point on the rectangular coordinate system. Now, in the polar coordinate system, we start with an initial point known as the pole, and from that point we draw a line straight horizontally to the right, and that is called the polar axis. Therefore, in the polar coordinate system, we have only one axis. It's known as the polar axis, and its initial point is known as the pole. And any other point will be described on this new system with reference to the pole, the initial point of the polar axis. So the foundation of the polar coordinate system is a horizontal ray that extends to the right. The ray is called the polar axis, and the endpoint of the ray is called the pole. A point P in the polar coordinate system is represented by an ordered pair of numbers r, theta. So any point, instead of using x, y, we will use r, theta. R will represent the distance of the point from the pole, and theta will represent the angle it makes along a straight line from the pole to that point with the polar axis. One of the coordinates of a point on the polar system will be an angle measure, right? Let's continue with our understanding of the coordinates of a point in a polar coordinate system. I will refer to this picture here given below. A point P has been shown in purple, and we represent that point using two coordinates r, theta. But let's go over the polar coordinate first. In any polar system, we have a point called a pole, and all other points on the coordinate system will be referenced relative to that pole. We see a line running horizontally right from the pole, and that's known as the polar axis. Now, the point P here we said is defined or described using the coordinates r, theta. What is r? R is a directed distance from the pole to P. In other words, if we connect the point to the pole with a line segment, then the distance of the point from the pole is known as r. It is, in other words, the length of this line segment. What is theta? Theta is an angle from the polar axis to the line segment from the pole to P. In other words, the angle made between the polar axis and the line segment connecting the pole and the point is theta. So theta is an angle measure. Theta is an angle from the polar axis to the line segment from the pole to P. This angle can be measured in degrees or in radians. Positive angles are measured counterclockwise, just like with standard angles. If we are referring to positive angles, then we go counterclockwise or in the anti-clockwise direction from the polar axis. Negative angles are measured clockwise from the polar axis. All right, so that is how we will be defining a point in the polar coordinate system. We will now work on an example to plot points in a polar coordinate system. The polar coordinates given to us is 3, 315 degrees, which means r has a value of positive 3 and the angle theta has a value of 315 degrees. Now, before we start plotting the point, let's inspect the polar coordinate system. In this picture here, we see a set of concentric circles. The circles are divided into 4 parts with a horizontal line and a vertical line, each running through the center of the circles. Now, the horizontal and the vertical lines are in no way the x and y axis. That concept does not exist in a polar coordinate system. They are just meant to divide the circles into 4 parts, giving us 4 quadrants, which is going to make things easy to draw our angle. But let's go on identifying the pole and the polar axis. At the center of the circles will be the pole, which is just a point, and then from the pole extending to the right is what's called the polar axis. Now, the polar axis is a reference point from where we start drawing our angle theta. So let's mark the different quadrantal angles here. The polar axis has an angle value of 0 degrees and then 90 degrees on top, 180 degrees diametrically opposite to the polar axis. We have 270 degrees at the bottom, and then when we come around one full circle back to the polar axis, we get a 360 degree angle. We start plotting the point by first drawing or sketching the 315 degree angle, sketching theta in other words. This is a positive angle, therefore from the polar axis, which is the reference point for the angle, we move in the counterclockwise direction, just like in the case of a standard angle. Let's draw the 315-degree angle first. This is a fourth quadrant angle, so it'll lie somewhere in the fourth quadrant. Therefore, from the polar axis, I will move in the counterclockwise direction and stop somewhere in the middle of the fourth quadrant. Let's stop here, and then let's draw our terminal side right here going down. So this is our 315-degree angle. I'll mark this 315 degree. In the next step, we will be plotting R. We plot R with reference to the pole. So the pole is the reference point where R would be located, but R will be placed along the terminal side of the angle we just drew. Because R is a positive value, it will be located along the terminal side. However, where along the terminal side is the question. It has a value of 3. Therefore, from the pole, we will have to move out 3 units towards the terminal side. Just count the circles. From the pole, this is 1, 2, and 3. The circles essentially give us a grid to locate R. So let's do 1, 2, 3. It'll be located somewhere here. Let's mark that point. So this is where it'll be located. So this point here will have coordinates 3, 315 degrees. So here are the steps we followed. Let's go over that. Because 315 degrees is a positive angle, draw theta equals 315 degrees going counterclockwise from the polar axis, correct? And then we have to plot R. For that, we will have to use the pole as our reference point. It says because R equals 3 is positive, plot the point going out 3 units on the terminal side of theta. So always use the pole as the reference point. From the pole, you are going out 3 units. Your circles are the guidelines, work as the grid to locate the point. So 1, 2, 3 units. And here is our point 3, 315 degrees. We will now work on a second example to plot a point with the polar coordinates of -2, pi. So here R has a value of -2 and theta has a value of pi. Now the fact that R is a negative quantity here, the process of plotting the point will be slightly different from what we learned before. However, to start with, we will first sketch the angle. So let's look at our polar coordinate system. We have the pole right at the center of the circles, and from the pole extends the polar axis all the way to the right. And let's mark the quadrantal angles: 0 on the polar axis, pi over 2 on top. We have pi on the opposite side of the polar axis, 3 pi over 2, and then when we come around a full circle back to the polar axis, we get 2 pi, correct? Now, the angle is pi, it's a positive angle. Therefore, we have to start from the polar axis going in the counterclockwise direction to the line that is pi, correct? So let's sketch that angle here. From the polar axis, we start in the counterclockwise direction and stop at pi radians. Now that we have our angle, we have to show where R is. Now, if R were a positive value, then the point would be located 2 circles out from the pole, correct? It would be located somewhere here if R were a positive 2. However, the fact that it's a negative quantity, the way to plot the point is go in the diametrically opposite direction of the pole. All right, so the point will be located 1, 2 units on the opposite side, correct? So let's mark the point. It would be located somewhere here on the polar axis, which is the line opposite the line which is pi, correct? Let's erase the other point here that we originally drew, and let's pull up the solutions at this point. So the first step is to draw pi, which is a positive angle. Draw theta equals pi counterclockwise from the polar axis. That's exactly what we did. We drew our angle. We started from the polar axis and sketched the angle first along the pi line. And the next step would be to plot R. And it says because R is -2, plot the point going out 2 units along the ray opposite the terminal side of theta, correct? So the terminal side is this pi line. We have to go in the opposite direction 2 circles out. Therefore, the point is located at -2, pi. All right? Here's a third example of plotting a point with the polar coordinates of -1 and -pi/2. In this case, both r and theta are negative, but the process is going to remain the same. Here's our polar coordinate system. Let's mark the pole, which is at the center of the circles, and the line extending from the pole all the way to the right is the polar axis. Let's mark the quadrantal angles: 0, pi/2, pi, 3 pi/2, and 2 pi. Those are the positive angles. If we are going in the negative direction, then this 3 pi/2 will become -pi/2. Then pi will become -pi, and pi/2 will become -3 pi/4, four negative angles. All right, and then this one will become -2 pi. You get the idea, correct? So r being -1, theta being a negative angle, we have to move from the polar axis in the clockwise direction this time, just because theta is a negative angle, correct? So from the polar axis, let's move up to -pi/2. So that will make it a quadrantal angle. This is where -pi/2, the terminal side, would be. So now that we got our angle, we have to show where r is. R is -1, it's a negative value. If r were a positive value, then the point would be located along the line of -pi/2, and it would be located somewhere here perhaps. If r were a positive value, only then it would be located at this point. However, r is -1, so we have to show the point in the opposite direction. Same line, but in the opposite direction to where the pole is. That means the point would be located somewhere here, right? Let's show it in green. This is where the point would be located, correct? And not here. Let's pull up the solutions. It says, because -pi/2 is a negative angle, draw theta equals -pi/2 by moving in the clockwise direction from the polar axis. That's exactly what we did. And then finally, to show r, because it is negative, plot the point going out 1 unit along the ray opposite the terminal side of theta. So the terminal side was -pi/2. Its opposite side would be the line of -3 pi/2. And that's why we have the point located 1 circle out along the line of -3 pi/2, just because r is a negative quantity. All right? Now we will learn how to find other polar coordinates for a given point. The question says, find another representation of the point 5, pi/4 in which r is positive and the angle theta is between 2 pi and 4 pi. Now the way to go about it is first plot the given point, and then we will use that as a reference point to find another point which meets the conditions that they have asked for. So 5, pi/4. Pi/4 is a first quadrant angle. It's an angle within the interval 0 and 2 pi. So it'll be an angle right between the polar axis and this vertical line going up. Let's mark the pole and the polar axis because all angles will be sketched with reference to the polar axis and all values of r will be shown with reference to the pole, correct? So this is the pi over 4 radian angle. And now we have to plot 5, which is the value of r. And for that, we use the pole as the reference point and the circles as the grid, right? So 5 units out from the pole towards the terminal side. So 1, 2, 3, 4, 5. The point will be located on this outer circle along the terminal side of the pi over 4 radian angle. So let's locate the point here, somewhere here. That's 5 comma pi over 4. Now we have to find another point which meets the condition that r is still positive and theta is an angle between 2 pi and 4 pi. 2 pi and 4 pi has a period of 2 pi, correct? So that means if we go around 2 pi units from the terminal side, we'll come to the same point. Therefore, the value of r will be the same. However, since we've gone around another 2 pi to get to this terminal side, we will have to add 2 pi to the pi over 4. All right. So in other words, here's what we are doing. From this terminal side, we go a full 2 pi units and come and rest on the terminal side again. So to the pi radian, we have to add 2 pi to get our new angle value of another point. Therefore, it says here we want r positive and theta between 2 pi and 4 pi. We can find the new angle value by adding 2 pi to the angle, but we do not change r. Correct? So here's the process. 5 comma pi 4 was our original coordinates of the point. We are going to add 2 pi to just pi over 4. The value of r doesn't change. When we do that, we have to, of course, perform a fraction addition. Pi over 4, 2 pi can be rewritten with a common denominator of 4. The numerator becomes 8 pi. So 8 pi over 4. And then once we perform the addition, 5 comma 9 pi over 4 are the coordinates of the new angle that they've asked for. All right, so we have the point as 5 comma pi over 4. If we go around one full circle to the terminal side, we will end up this point. Let's just color it differently. The same point will have coordinates 5 comma 9 pi over 4. All right. Let's look at another example of finding an alternate polar coordinate for a given point meeting certain conditions. The point given to us is 5 comma pi over 4, which is the same that we used for the previous example, but it says here r must be negative and it must be an angle measure between 0 and 2 pi. In other words, theta must be a value between 0 and 2 pi, but it cannot be pi over 4, and r must be a negative value. In other words, the coordinates of the new point must have r as negative 5. We have to figure out what theta will be for the new point. We start by plotting the point given to us, the original point, which is 5 comma pi over 4. That was located right here, correct? So let's mark that point. This is where 5 comma pi over 4 is. Now, if r is negative, then it'll be located in the diametrically opposite direction to where the original point was, to where the positive 5 would be located. So here we have our pi radian angle. This is our pi 4 radian angle, and positive 5 units away from the pole is where the point 5 comma pi over 4 is located. To show the negative 5, we have to extend this terminal side of the pi over 4 radian angle in the opposite direction, making it a straight line. So the terminal side is going to be an extension in the opposite direction of the pi over 4 angle terminal side. All right, so this is our new terminal point where -5 would be located. So let's locate -5. This is where -5 would be located, and we have to find this angle measure, which starts from the polar axis. It should include the pi over 4 and extends another pi units, another pi radians to the new terminal side running diametrically opposite to the terminal side of pi over 4. All right, you get it? Which means we have to add pi radians to our existing pi over 4 radian angle. Correct? So let's go over the steps. First of all, we want r negative and theta between 0 and 2 pi. In order to find theta, so add pi to the angle. The process is to add pi to the angle and replace r with -r. We already did that. We changed the r to -5, but we have to find theta. How do we find theta for this particular condition? We have to add pi radians to pi over 4. Correct? So 5 comma pi over 4 will be equal to -5. We change the 5 to a negative value and add pi to the original points pi over 4, and we will end up with -5 comma pi over 4 plus 4 pi over 4 is the equivalent of pi. We just gave it a common denominator of 4. We can just add the numerator values here. We'll end up with -5 comma 5 pi over 4, and those are the coordinates of the new point here. So we can write here -5 comma 5 pi over 4 as the coordinates of the alternate point. All right. Let's look at a third example of finding an alternate polar coordinate for a given point. We are given that same point 5 comma pi over 4, but this time for the new point r will be a positive value and theta will be a negative angle between -2 pi and 0. So r is not changing, it's going to be a positive value. Let's plot the original point 5 comma pi over 4. It will be located right here, 5 circles away from where the pole is, and the angle for pi over 4 is this angle here from the polar axis to the pi over 4 radian angle. Correct? This is the terminal side of the pi over 4 radian angle. Now find another point which has a negative angle value between -2 pi and 0. Because it is a negative angle, we have to move in the clockwise direction from the polar axis, correct? Therefore, this is what we are looking for here. This angle starting from the polar axis all the way around and stopping at the terminal side. So if we subtract 2 pi from this pi over 4 angle, then we will get the measure of this green angle starting from the polar axis and terminating at the same terminal side. So that's the steps that we complete here. We want r to be positive and theta to be a negative angle, but within -2 pi and 0. Subtract 2 pi from the angle and do not change r. And that's what's being done. We have r as 5, and from the pi over 4 radian angle, we subtract 2 pi. When we complete the subtraction of the angle, we end up with coordinates 5 comma -7 pi over 4 as the value of the new point. So the new point will still be located here where 5 comma pi over 4 was, but now the angle is a negative angle, all right, because we have gone in the counterclockwise direction to come to that same terminal side. All right.